In this video, we're going to go over the properties, uses, as well as naming rules for carboxylic acids and esters. Okay, so please note that even though these notes focus on the naming rules for carboxylic acids and esters, you are still going to be expected to be able to name them as well as draw them. The reason why the notes focus on naming rather than drawing is just because naming is the harder of the two skills. So for carboxylic acids, this is a functional group that looks like this. Okay, so we have carbon double bonded to oxygen and then single bonded to an oxygen and a hydrogen here. Okay, so usually the COOH group is at the end of the molecule, and they can be recognized in the structural formula by that COOH at the end of the formula. Okay, so one important detail just to note, you do have to be careful with spelling here. Okay, so carboxyl, that's that COOH. Okay, it is not the same as carbonyl. Okay, carbonyl is a different type of functional group, so just be aware of that. So carbonyl is not the same thing as carboxyl. Okay, so carboxyl is this COOH functional group, which is a part of carboxylic acids. Okay, whereas carbonyl, what that is you have carbon attached to some chains of carbon, but it's only double bonded to oxygen. So just be aware of that. Okay. And just as a quick reminder, these squiggles here represent the same thing as the R in this diagram, which just means it's some unspecified carbon chain. Okay, so some properties of carboxylic acids is they're going to be polar, and that's because of the presence of oxygens in the compound there. So because they're polar, they're going to dissolve in water, which is another polar substance. They're going to have pretty high boiling points just due to the fact that they can hydrogen bond, they will have dipole-dipole attractions, and they will have London forces. As the name carboxylic acid indicates, these are acids, however, they're going to be weak acids. And some diagnostic tests that we can use to determine if a substance is acidic is litmus paper. It's going to turn red in the presence of acids. Acids readily react with metals, and they also neutralize bases. Where you're going to find carboxylic acids is in a variety of different places here. So, for example, methanoic acid is used to help recycle rubber. Ethanoic or acetic acid, you're going to find that in vinegar. So vinegar is usually like a very low percent of acetic acid, like 5%. Oxalic acid is used as a rust remover, and citric acid, you'll find that in fruits. It's what gives fruits its sour taste, and it can also be used in candies to give the candy a sour taste as well. Okay. Off to the side here, you're going to want to know some common names for carboxylic acids. So these don't follow the IUPAC rules for naming compounds here. Like the common names kind of follow an older naming system. Okay, so the first one we're going to talk about is methanoic acid. Now, the common name for that is going to be formic acid. So again, the common names, they don't follow IUPAC naming system. Then the next one is ethanoic acid. The common name for that is acetic acid. So if you're wondering if you have to memorize the common names for methanoic acid and ethanoic acid, the answer is no. If you go to your data booklet and if you go to page 8 and 9, you'll be able to find them. So the bottom of page 8, formic acid is put there alongside methanoic acid, so you don't have to memorize that one. Okay, and then for ethanoic acid, you'll find it near the top of page 9. So you don't need to memorize the common names for these carboxylic acids. You can find them in your data booklet. All right, so let's get into the rules for naming carboxylic acids. So again, you're going to want to figure out where your parent chain is, and the parent chain should be including that carboxyl group, so that COOH group. Okay, and the carbon in the carboxyl group is always going to be considered carbon number 1. And then to name carboxylic acids, you're going to start off the name kind of like how you would name an alkane, but you're going to drop the E in the alkane name and replace it with oic acid. So drop the E from alkane name and then replace it with oic acid. Okay. So for this first example here, they've given us a structure along with the chemical formula there. I'm just going to focus on this structure. Okay, so our parent chain, is right here. Okay, so that's our carbon number 1. Since there's only one carbon in our parent chain, the prefix that means one carbon is meth. Okay, now at first we would start with our alkane name, methane. However, according to our rules, we got to drop that E and then add in oic acid. So this is methanoic acid. Okay, so this oic acid part, when you're trying to go from a name to a drawing, that's your key indicator that your compound is a carboxylic acid. Okay, or that's the specific suffix that tells you you have a carboxylic acid. Okay. So once again, they've given us the structure and the molecular formula for the same compound here. I'm going to focus on the structure that we're given here. Okay, so there's our parent chain. We've got 2 carbons in our parent chain. Okay, so again, I start with the alkane name, but I'm going to drop the E because of this functional group here. Okay, that's that carboxyl, and I'm going to replace it with oic acid. Okay, for our next one here, there's that carboxyl functional group, and attached to it we have benzene. Okay, so because what's attached to the benzene, there's 6 or less carbons, we're going to treat benzene like it's a parent chain. Okay, so I'm going to start off with benzene. Now what I'm going to do with this is I'm going to change this ENE ending to the oic acid. Okay, so because we're not just changing or dropping the last E and switching it to oic acid, this does mean that benzoic acid does deviate a little bit from our rules, but the nice thing about this is that you can go to your Chem 30 data booklet and look up benzoic acid right here on page 9. Now, moving on to the next example here, we have oxalic acid. So this one is another tricky one, but once again, we just have to look at our data booklet, and you can find this on page 8, right near the middle. Okay, so once you find oxalic acid, it'll tell you the formula right here. So it's HOOCCOOH. So we can go to our notes, and I'm just going to color code this so that you can track where everything is.
Yes.
All right, so that's the molecular formula. Now, if I was to draw the structural formula of this, how that would look would be here. So C Okay, so this first part is the blue HOOC. Okay, and then there's the other half of oxalic acid. Okay, so as you can see, there's 2 carboxylic acids that make up oxalic acid. Okay. Now for the last one, 4-methylpentoic acid, how we would do this is I like to start with the parent chain. Okay, so that's the last half of the name. So pentanoic acid means that there's 5 carbons in the parent chain. Okay, with the carbon at the base of the carboxylic acid being carbon number 1. So how I would do this is I'd go 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. Here we go. Okay, and I would go for my carboxylic acid like that. Okay, so numbering the carbons, here's how you would do it. So 1, 2, 3, 4, 5. This carbon, it's very sneaky. Oftentimes students forget to count this carbon as part of the parent chain. Okay. All right, so that is the parent chain taken care of. Now we need to worry about the branch, the 4-methyl. Okay, so on carbon 4, we have a methyl group. That's what that's saying. So I gotta scoot this over. And there we go. Okay, so this would be the line structure drawing for this compound 4-methylpentanoic acid. Okay, and let's just write the little note that I talked about. I just didn't write it down. Don't forget to count this carbon in the parent chain. Okay. Now we're moving on to esters. So esters, what they are a combination of carboxylic acids and alcohols. Okay, and we'll get into exactly which part comes from the carboxylic acid and which part comes from the alcohol. So what this functional group looks like for esters is you're going to be looking for this carbon double bonded to oxygen and then single bonded to another oxygen, but the oxygen, instead of being attached to a hydrogen, which would make it a carboxylic acid, it's attached to a carbon chain, okay? And then the carbon at the base of the double bonded to oxygen, that is also attached to another carbon chain. So the R and the R prime, that just means that these are two different carbon chains, okay? And in addition, like, R doesn't necessarily just mean carbon, it could just mean hydrogen as well. But keep in mind that this R prime can't be a hydrogen because that would mean it's no longer an ester, it's a carboxylic acid. So just keep that in mind. So this is what the ester functional group looks like. So you do need to be able to identify all of the functional groups just by sight. You need to be able to name and draw all of your hydrocarbon derivatives. So that's your alcohols, your carboxylic acids, your esters, and your organic halides. So properties of esters, they're going to be polar. Small esters can dissolve in water, however, large esters can't dissolve in water, and that's just because they, like large esters, what that means is that these carbon chains, if they get very long, that means there is like significant portions of the compounds that are nonpolar, and that's what prevents it from dissolving in water. Boiling points are slightly lower in esters compared to the corresponding carboxylic acids and alcohols, but that's just due to a lack of hydrogen bonding. Okay, so again, that comes back to the less intermolecular forces there are, the lower the boiling point. The higher the intermolecular forces, or the more the intermolecular forces there are, the higher the boiling point. Okay, esters are pretty volatile, which allows them to generate aromas. So that's why they're often used as flavoring agents as well as scents. So if you wanted some examples here, okay, of some esters that are used as flavors or scents, you got a whole list here. So for example, the N-amyl acetate, that is going to smell like pears or bananas. So that is what is used, like if you're thinking of banana candy, that would be used to give it that banana flavor. Okay, apples, they have methyl butyrate in them that gives them that apple taste. But as it says below here, the interesting part about esters is that, like, since they're made up of alcohols and carboxylic acids, if we looked at the alcohol and carboxylic acid that makes up the esters individually, right, the alcohols and the carboxylic acids individually are toxic to the body. So, for example, that methyl butyrate that's in apples, methanol, so the alcohol that contributes to that ester, is actually poisonous. And butyric acid, which is a carboxylic acid that reacts with methanol to give you methyl butyrate, that's actually the compound that's responsible for the smell that rancid butter has. Okay, so it's an interesting point to kind of consider how, like, compounds, like if you change small things about them, they have an entirely different effect on the body. All right, so before we move on, I did talk about this, but I just want to write this down. Okay, so R prime can't be hydrogen because otherwise this would change this from an ester to a carboxylic acid. All right, so rules for naming esters. So step 1, identify the alcohol that was used to make the ester. Okay, and once you figure out the alcohol, you're going to take the alcohol name and change the ending to YL. Okay, and then the second part is you're going to identify the carboxylic ester used to make the ester. And from the carboxylic acid name, you're going to drop the oic acid and replace it with O8 to create the ester name. Okay, so after you figure out those two parts, you're going to put the names together, but just make sure you have a space in between them. And then you can have branches on ester, but again, they're going to follow that alphabetical rule, and the numbering is going to begin at the oxygen end of the alcohol, okay, and the carbon double bonded to the oxygen end of the carboxylic acid. Okay, so what's important here when you're looking at an ester is you got to figure out where to kind of break the compound apart so that you can figure out, okay, which part's coming from the alcohol, which part's coming from the carboxylic acid. Okay, so you're going to want to create that break point in between the carbon single bonded to the oxygen. Okay, so this part that's to the right of the break point, that's going to be the part that gives you the alcohol that you need to have in your name. Okay, so the alcohol part is going to come first in the name for the ester. Okay, and what I'm also going to write as a note, we'll just put it up here. Okay. So I said this out loud, just didn't write it out. Okay. First, locate the break point. Okay, so step 1, first locate the part where you're going to break apart the compound into its carboxylic acid part and its alcohol part. The alcohol part is going to be the part where the carbon is single bonded to the oxygen. Like anything beyond that oxygen, that's going to be the alcohol part. Okay? This part over here where we have the carbon double bonded to the oxygen, that's going to be the part that comes from the carboxylic acid. Okay, and the part that comes from the carboxylic acid, that goes last in the name. Goes last in the ester name, I should be saying. Okay, so we've got the main details here. Let's go on to some examples here. Okay, so first things first, identify the breakpoint. So that's going to be right here. Okay, so this part is coming from the alcohol. Okay, and then this other part is coming from the carboxylic acid. So the reason why I'm saying this part comes from the alcohol, this other part comes from the carboxylic acid, the reason why I'm saying that is because in order to get an ester, you need to react a carboxylic acid with an alcohol in order to produce an ester. That's why I'm saying that. Okay, so we know that the alcohol part comes first in the name. So let's take a look at the alcohol. So this has 2 carbons in the alcohol part. So if I was naming this as an alcohol, I would say that it's ethanol, because eth means that it has 2 carbons, the anol means that it's an alcohol. However, because we're trying to come up with a name for an ester, remember that our rules say that the alcohol part has to have that YL ending. Okay, so I would change it from ethanol to ethyl. Okay, now for the carboxylic acid, that comes last in the ester name. So we need to figure out how many carbons are present in the carboxylic acid, or in the part that comes from the carboxylic acid. Okay, so keep in mind you can't forget about this carbon, okay, because that's included in the parent chain. So I'm just going to underline it just because I don't want this to get too confusing with all the highlighting. Okay, but this is where our parent chain would be for the part that comes from the carboxylic acid for this ester. Okay, so I can see that there's 4 carbons in this part. So the prefix that means 4 is but, and if I was naming this as carboxylic acid, so remember you start off with the alkane name, but then you drop the E and replace it with oic acid. Okay, so switching from the carboxylic acid name to the ester name, it says that we have to drop the oic acid and replace it with O8. So that's what we're going to do. So that would be butan O8. Okay, so this ester is named ethyl butanoate. Moving on to the next example, again, let's just figure out where our breakpoint is, and I'm just gonna say right there. Okay, so now let's look at the alcohol part. So I'm just gonna label this alcohol. Why? Because this is the part that was single bonded to that had a single bond between carbon and oxygen. Okay, now where's our parent chain? Parent chain's going to be right here. Okay, so for the alcohol part, it's got 3 carbons. The prefix that means 3 is prop. If I was naming this as an alcohol, I would call it propanol. Okay, but in the ester name, it would change from propanol to propyl, because you got to take that anol ending and switch it to YL. Okay, now let's look at the carboxylic acid. So that's this section. I'm going to abbreviate carboxylic acid to Ca. The parent chain is right here, so there's 3 carbons in that parent chain. So if I was naming that carboxylic acid, the prefix that means 3 is prop. Okay, and as a carboxylic acid, I would call that propanoic acid. But for the ester name, remember we have to take out that oic acid part and switch it to O8. So this would change to propanoate. So propanoate. Okay, next one here. There's a break point. Here's the alcohol. There's the carboxylic acid. Okay, so something just to keep in mind, for all of these examples, the alcohol happened to be on the right-hand side of the compound. However, that isn't always the case. Okay, so keep in mind that alcohols don't have to be on the right-hand side of the compound. They could be on the left-hand side. Same with carboxylic acids. They're not always on the left-hand side of an ester structure. They could be on the right. Okay, that's why it's so important to figure out where that break point is, and the part that has this carbon single bonded to the oxygen, that's going to be the alcohol part. The other half that has the carbon double bonded to oxygen, that's going to be the carboxylic acid part. Okay, so let's just make sure to just write this as a note to ourselves. So I'm abbreviated carboxylic acid just to Ca. Okay, so when I say alcohols don't have to be on the right-hand side, I mean the part of the compound that comes from the alcohol when you're reacting substances to get the ester. Okay, same for carboxylic acid. I'm meaning like the part of the ester compound that comes from the carboxylic acid in the reaction to produce the ester. All right, so let's take a look at this. So the alcohol part, that's got 2 carbons in it. Okay, so the alcohol would be called ethanol. However, we got to change that ending to YL, so that would be ethyl. Now looking at the carboxylic acid part, it's very tempting just to say that this is the parent chain. However, keep in mind that's not the longest continuous chain of carbons. Okay, so that is actually the parent chain. So there's 4 carbons there, and we also have a branch on it. Okay, so if I was naming this, okay, so as a carboxylic acid, okay, the branch, numbering it, I would go 1, 2, 3, 4, because remember this carbon always has to be carbon number 1. Okay, so if I was naming this as a carboxylic acid, I would name it as 2-methyl butanoic acid. But because it's an ester, we drop this oic acid part and change it to O8. Okay, so then that would change this to 2-methyl butanoate. Okay. So keep in mind that all of the names that are in the boxes, those are the names of the esters. Okay. The names that I put above, that is just kind of the background work to show you how we can start from the alcohol name and the carboxylic acid name and use that to help us name it as an ester. Okay. So keep in mind, these are the actual names of the esters.